Hello and welcome to AS and Advanced GCE Mathematics. Feedback on June 2015, Unit FP3 pre-recorded event. Here are the aims and objectives for the session. In this training session, you will receive feedback on national performance of candidates in Unit FP3 of the June 2015 examination series. Consider the variation of candidates' performance on different questions and possible reasons why. Discuss the examiner's reports. Address common issues and FAQs. Here's the outline that we will be following during this training session. Introductions, delegate polls and agenda. Introduction to the FP3 qualification and feedback on the FP3 June 2015 examination. Common issues, further training, any questions. Finish. Now we're going to start with the introduction to FP3. Here's a screenshot of the specification. Please download it from the website if you think it's necessary. The paper was found to be accessible to a wide range of candidates. The mean score was 47 out of 75. This paper proved a good test of candidates' knowledge and candidates' understanding of FP3 material. Timing did not appear to be a problem, as most candidates seemed to finish the paper. Many candidates found the unstructured question in 8C challenging. This question tested hyperbolic equations. The vast majority of candidates correctly used the identity cosh squared x equals 1 plus sine squared x to obtain a quadratic in sine x. Most then used the logarithmic form of r sine to obtain the final answers. Some candidates wrote sine x in terms of exponentials and proceeded to solve the resulting quadratics in e to the x, and sometimes ended up with extra solutions that were not rejected. A significant number of candidates attempted to solve the given equation by expressing it in terms of exponentials. Such solutions usually stopped once a quadratic in e to the x was reached. Candidates who adopted this approach realized that any progress would be difficult and so resorted to using the identity cosh squared x equals 1 plus sine squared x. The vast majority of candidates correctly used the identity cosh squared x equals 1 plus sine squared x to obtain a quadratic in sine x. Some candidates wrote sine x in terms of exponentials and proceeded to solve the resulting quadratics in e to the x. A significant number of candidates attempted to solve the given equation by expressing it in terms of exponentials. These attempts usually made little progress in solving the original equation. This question tested the ability to find the length of a curve. This was a good source of 5 marks for many candidates. Some candidates who, although they started with a correct arc length formula, forgot to take the square root and so unnecessarily ended up integrating cosh squared x. The use of limits was generally sound, and very few candidates failed to give their answers in terms of e. Some candidates started immediately with integrating cosh x, and so were presumably finding the area under the curve rather than the length. Although this gave the same answer, the benefit of doubt was not given. Many candidates knew the method required and integrated correctly. Some candidates started immediately with integrating cosh x, and so were presumably finding the area under the curve rather than the length. Although this gave the same answer, the benefit of doubt was not given. This question tested finding eigenvalues and eigenvectors and diagonalizing a symmetric matrix. In Part A, the vast majority of candidates knew how to find the eigenvalues of the given matrix, although there were a surprising number of errors when forming the characteristic equation. Candidates may have been surprised to find two irrational eigenvalues, but persevered in Part B and often found suitable eigenvectors, although there were quite a few arithmetic slips, and some candidates forgot to normalize or possibly did not know what normalized meant. It was clear that some candidates were unaware of the result in Part C, and although they sometimes knew what P was, proceeded to calculate D from P transpose AP with mixed results. Those who did know what P and D were could often gain 2 follow-through marks here despite earlier errors. In Part A, there were frequent errors when forming the characteristic equation. This question tested integration techniques. In Part A, the majority of candidates began by completing the square correctly and identifying the r-cosh form, although a few gave r-cosh x over 2 rather than r-cosh x plus 1 over 2. Part B was met with less success, and it was surprisingly common to see 2 pi integral y squared dx quoted for a volume of revolution, and some candidates attempted to use the formula for surface area. Those who were integrating y squared could often score the middle 2 marks by using correct logarithmic form, either from direct integration or by using a substitution or partial fractions. Candidates scored well in Part A, but sometimes used an incorrect formula in Part B. This was a question on vectors. In Part A, most could find a correct equation, although some stopped, having found the direction, and some did not give the line as an equation as requested. Very few candidates gave the vector product form. Most candidates knew the necessary form in Part B, although some did not understand what was meant by the Cartesian form and offered the equation of a plane or simply left this part blank. In Part C, most knew that a normal was required and used 2 vectors in a plane, although some attempted to use 2 position vectors. Some candidates found a parametric form for the plane and then stopped. The method in Part D was well known, and those candidates with an incorrect equation in Part C could recover a mark here. The majority opted to calculate P, divided by the length of their unit normal vector, although some used a general perpendicular from O to the plane and then calculated its length. In Part A, many candidates stopped once they had found the direction of the line. In Part B, some candidates gave the equation of a plane. A variety of correct methods were seen in Part C, such as using a general perpendicular from O to the plane and then calculating its length. This was a question on the hyperbola. The mark in Part A was almost always scored, although x equals plus or minus 1 was seen a few times. Candidates were well rehearsed with the standard work in Part B, and errors were relatively rare. In Part C, candidates made some progress, although errors in establishing the coordinates of Q and R were quite common. Most knew the method to find a midpoint, although some subtracted the coordinates rather than adding. Some candidates wisely opted to work with the coordinates in exponential form, and this simplified the work significantly. Candidates generally struggled with Part D. it seemed that many were unaware of the right angle at O and tried various unsuccessful ways to find the area of OQR. It was common to see OP being used for the height of the triangle. Candidates were more successful in Part C when they worked in exponentials. This was a question on reduction formulae. Many correct proofs were seen in Part A. The most common approach was to write sine to the nx as sine to the n minus 1 x sine x, and then attempt parts, although a significant number of candidates differentiated sine to the n minus 1 x as n minus 1 sine to the n minus 2 x, and potentially lost a significant number of subsequent marks. Some candidates wrote sine to the nx as sine to the n minus 2x sine squared x, and then used sine squared x equals 1 minus cos squared x and proceeded correctly. For those who attempted Part B, the first 2 marks were often scored with one application of the reduction formula using the given limits. To score any more marks, candidates were required to identify that I1 would need to be evaluated at some stage. Those who did evaluate I1 usually scored all 4 marks. Candidates who had struggled with Parts A and B sometimes picked up all 3 marks in Part C once they realized that I5 minus I7 was required. However, some struggled applying the formula from Part B. In Part A, some candidates were unable to make a correct start with the integration by parts. Candidates who realized I1 was needed were more successful in Part B. This question was on the ellipse. The majority of candidates could make some progress in Part A, although there were some arithmetic slips. Candidates very rarely used the wrong eccentricity formula, but sometimes the foci were not given as coordinates. Part B proved to be a challenge for many candidates, although those who knew the focal property of an ellipse could achieve the result with minimal effort. Those who opted for an approach using Pythagoras had various degrees of success and often struggled with the algebra. Some chose to prove the result for a specific point, for example, 0, 1, and generally this was given no credit. Part C proved to be very challenging, with many candidates not knowing how to start. Substitution of y equals mx plus c into the ellipse proved to be a common approach, but candidates then often tried to solve the resulting quadratic and made little progress. The other most common approach was to use the parametric form for 2 ends of a chord and then apply the factor formulae. In general, fully correct solutions to Part C were very rare. In Part B, those candidates who knew the focal property of an ellipse could achieve the result with minimal effort.